Hi, let's take a look at a couple questions from Chapter 3 that typically give students some difficulty. One of them, of course, is the percentile problems. We're going to take a look here at the first one. It says below are 36 sorted ages of an acting award winner. Find the percentile corresponding to the age 75. This little box to the right-hand side is very convenient because this little box will click to open in StatCrunch, where the data will all be sorted for us. So we can take a look at StatCrunch here and scroll down the list to where we see 75. That shows us that right below that there are 33 pieces of data. So 33 out of 36. So to find the percentile, we're going to take 33 divided by 36 on our calculators. You're supposed to get 0.91666667. It says to round to the nearest integer. Well, when you multiply it by 100, you get 91.66666666, so forth. So we're going to round it to 92 and check our answer. So that is correct. The percentile for a 75-year-old person is 92%, meaning 92% of the actors were below 75 years old. Now, another question that typically causes students some frustration in Chapter 3 is working with the Z-scores. Sometimes as a result of overthinking. So let's take a look at this one. It says a particular group of men have heights with a mean of 181 centimeters, a standard deviation of 8 centimeters. Earl is 192 centimeters tall. What is the positive difference between his height and the mean? That simply just means how much taller is he than average. So we subtract. Now, in terms of the standard deviation, how many standard deviations is he? Well, one standard deviation is 8 centimeters. He's 11 centimeters taller. So he's a little bit more than one whole standard deviation. So we're going to divide 11 by 8. And then we're asked to round to 2 decimal places. So your calculator should show you 1.375. So we're going to click 1.38. Now, the Z-score is found by finding the difference between the individual score and the mean and dividing by the standard deviation. Well, here's the numerator, the difference between the score and the mean. Here's the part where we divided by the standard deviation. So we just found our Z-score. Earl's Z-score is 1.38. He is 1.38 standard deviations above average. Is that unusual? No, it's not unusual. Remember our definition of usual. Oops, I clicked the wrong one. Our definition of usual is that it needs to fall beyond 2 standard deviations from the mean. And again, be careful as you read. What I just did is a common mistake for students. I'm kind of going through my assignment and I need to take the time to read the questions, be sure that I'm carefully selecting the correct answer. In number 10 here, we're looking at BMIs from the 1920s and 30s and more recent winners for beauty pageants, and we are asked to find the coefficients of variations for both sets of data. So the first thing you're going to do is click to open these data sets in StatCrunch. And you're going to do summary stats for both columns. Use the control key to select both of those. Now for doing coefficient of variation, you really only need the mean and the standard deviation. So if you want to go ahead and hold down your control key and click mean and standard deviation, you will get a little printout that simply has those two important pieces of information. Now, to find the coefficient of variation for the 1920s, you're going to take your standard deviation, 1.4607456. You're going to divide it by the mean, 20.16. And we're going to look back at the answer. It wants us to show 2 decimal places as a percent. Now, on your calculator, you should see 0.072457. So first of all, we're going to multiply by 100% to convert it to a percentage, and then round off to 2 decimal places. So we're going to put in 7.25%. We're going to go back to our printout, and for the BMI for the other ones, we're going to put in 1.1568636. divided by 18.75. Here we're going to get 0.061699. So when we convert to a percentage and then round off to 2 decimal places, we are going to be looking to 6.17%. Excuse me. So now we're looking, is there a difference in variation between the two sets? And I'll leave that part up to you. Now keep in mind, is there a significant difference or is it not significant? So keep in mind as you think about what those terms mean. Good luck.